Let's take a look at the first IMO problem. Prove that the fraction 21n plus 4 by 14n plus 3 is irreducible for every natural number n. Do pause the video for a couple of minutes and give it a try on your own. Now let's move on to the solution. There are many ways to solve this problem. We will look at one such easy and quick way. Irreducible just means that the fraction 21n plus 4 by 14n plus 3 will never equal an integral value for any natural number n. So if we let f be the fraction given, then we have to show that f is never an integer. Let us try to simplify this by writing the numerator as the sum of denominator plus some x which we don't know yet. So we have that 21n plus 4 equals 14n plus 3 plus x. Now we subtract 14n plus 3 on both sides to get the following. Hence we have that 21n plus 4 equals 14n plus 3 plus 7n plus 1, which is nothing but x. So we plug this back into f to get that the numerator can be rewritten as such. We can now split the numerator in the following way. The first term is nothing but 1 and the second term stays as it is. If we now say that 7n plus 1 be m, then notice that 14n plus 3 can be written as twice 7n plus 1 plus 1. This just implies that 14n plus 3 can be written as 2m plus 1. This means that f equals 1 plus m by 2m plus 1. We now make use of a simple inequality. Remark, since n is a natural number, m is also a natural number. Then 0 is less than m and m is less than 2m, which also means that m is less than 2m plus 1 are both trivially true. Combining both of these inequalities, we get that 0 is less than m and m is also less than 2m plus 1. Now we divide this whole inequality by 2m plus 1. The direction of these inequalities need not change since 2m plus 1 is positive as m itself is positive. We now have that 0 is less than m by 2m plus 1 is less than 1. We now add 1 to both sides of the inequality to get the following. But recall that we let f be 1 plus m by 2m plus 1. So now we have that 1 is less than f is less than 2. Here f cannot be an integer since it is sandwiched between two consecutive integers. Hence we have shown that f, which is 21n plus 4 by 14n plus 3, is never an integer. There also exist quite a few other solutions to this problem. Do try to solve it in an alternative way. The hint here is that use some known theorems about divisibilities. Thank you for watching and hope you learned something new.